Yeah, fourth and freshman.
Oh.
Okay.
And then there was.
I haven't done my IRB paper back there.
The highest level of spray tan.
Oh.
Who is this diva? Yeah.
First off, I have to say, it's actually a really nice teaching class when your iPad works.
Yeah, for no, but it's not working. Hey, that's a sensitive subject.
Working.
Oh.
Because I didn't know what was going on.
Basically, like, to some term, you're supposed to put 25 hours.
I'm just, it's a.
into the class.
Honestly, I didn't know, but, another professor in my department ratted you out.
I bet it was that Keegley. She's the one who mentions it.
Yeah, she made fun of me the other day. But
We were supposed to be like 2 weeks ago, so I didn't get.
Okay, so we're talking about center of mass. So. We're gonna use it. I don't know, I guess an easier diagram to think about this, if you wanted to really think about it in the general sense.
That's a great reason. It's not not.
just to
You
help.
can imagine you just have some kind of amorphous mass
I wish that worked.
with little points all over that you can consider as individual masses.
Like a thing.
That's mass I, and then somewhere in the center, somewhere, once you figure it out, you got the center of mass, and then everything is measured.
You have it, you're perfect. That's right. Feel good, you don't.
That's the generalized way to do it. Now, that kind of vector, what is that? Position vectors. So of course, you'd have to have the position vectors of each and every single mass, and this would of course be in multiple dimensions. But we can actually break this down and do it in a single dimension. Okay, so let's say we have. That's one.
Might be homework.
We have math two.
Like, how we're so just like. This is really good. You should see it.
It's so repulsive.
So we imagine these on an XY axis. Now here's a question. Let's just see how your physics intuition is. The center of mass. So like, let's say this system's balanced, okay? And to understand what we mean by balance, we're gonna get into that. Let me introduce a topic called torque that we'll go into in more detail later. But if you were to try and guess where the center of mass of this system, would it be closer to the larger mass in two or the smaller mass in one? Larger mass. We could say like, you have a center of mass there, and then you can start to figure this out. You're saying, well,
Very far.
if we do this in one dimension, our position vectors end up becoming, we have distance x1. The position of the center of mass.
Yeah.
This is a much simpler way to look at it. So we're going to be looking at center of mass in terms of single dimension instead of position vectors. Okay, now of course, like always, I put the center of mass theorem on here. But we need to know where it comes from. Okay, so center of mass comes from an idea called torque. So you know each one of these masses. It's going to have a gravitational force. Okay, the way to think about torque. I don't know,
I don't want to sit by it.
when you apply torque to something, how does it cause the object to move?
How do you make the object move?
Yeah, how does, what kind of motion does the object move in?
Opposite direction. Well,
No, it would be real simple about
the long, towards like the longer the lever, the easier it is.
it. It is, so you can think of it as like you put a wrench on a bolt, and you point,
Yeah.
if you work the wrench, how does the circle? So we're gonna say you have a pivot point right there. So each one of these masses is gonna, no, actually move the pivot. We're gonna put the pivot point in the center of mass, that's where it goes. So, that because if we put it at the origin, it's not gonna be a balanced system.
Yay.
Okay, now,
Yay. I'm not going.
we've learned how to multiply vectors in one way. What was the way we learned to multiply vectors? Dot product, which is also known as the. Does it produce a dot product produce a scalar or a vector? It's a scalar product. Now, we're gonna learn the torque is going to be,
What is that?
it's an alternate way of writing a Greek letter tall. Now we have a new type of vector multiplication. What do you think this one's called?
Tall.
Cross product, or the other one's a scalar product. This one is the vector product. Okay, and just like the dot product, there are two forms to this. The one you'll use more often, and we'll talk about the unit vector in a second, because what?
In this one pocket.
Okay. So the generalized format of this is going to be R and F. What the heck? So as the dot product was cosine of theta between the two angles, the cross product becomes dot product is cosine. Cross product becomes sine of theta between the two vectors. And you notice that I just put a general torque, a unit vector on there that says in the direction of the torque. Okay, we'll talk about this more later, because I want you to try to wrap your mind around. This is where it's fun. This is the same kind of idea you're going to have when you have electric particles in a magnetic field. So if I'm torquing this way, if I'm torquing this way.
That way?
Johnny Jesus. No, no. Yeah, but I don't actually know how to say this now that y'all are going to take us some. Okay. I have a system. It's undergoing a force of torque.
But you can't say that. Oh, it's.
And it's going in a circle.
He's working in a circle.
That's hard to torque in a circle.
Sorry.
Go to confession.
Like.
Yeah, I'm not Catholic.
Sure. Anyway, the object moving around in a circle. Now, so torque isn't energy, okay? which way do you think the energy vector is pointing? So, so if it's turning this way,
It's down.
is it down? How do you, why?
I don't
Where's
know.
gravity?
No, not force. Well, force of gravity is causing the circular motion. It's causing it to move like this,
Yep.
but which, okay. You have two cars on the road. They're both their wheels are going. What happens if their wheels get too close in touch?
The two different motions.
Yeah, they fire off of each other. Why?
It's going this way, so it's going towards each other.
The torque energy, in physics, we have these things called a right hand rule.
Spell torque.
No, TRQUE. So the right hand rule says, basically like, and we'll talk more about this later. If I take so the force is down, the lever arm is this way. And if I cross one into the other, the way my thumb is pointing shows me the direction of the energy vector. So even though the object's moving in a circle, the energy vector goes straight out that way. Right hand rules, this is probably the easiest one, so I would practice it. Because once you get to electromagnetics, it gets a lot more abstract. Because like, for example, you throw a charged particle into a magnetic field, how does it move? Well, imagine it's moving in with a velocity this way, it hits a magnetic field, how does it start to move? It's spiral. Because again, magnetic force, so, okay. Electric particle moving that way. Magnetic force forces it that way. But, so that's why, for example, when you have two like wheels that are moving and they touch each other, they fire off of each other. You have two opposing torque vectors pushing against each other. Okay. So that's why I put the generalized unit vector on there. Because you really have to try, like, look at the motion. But again, right now, we're just worried about the basic idea of each one of these masses has a gravitational force. It's going to try to pull it either way. It's like when you were in grade school, you have the whole teeter-totter thing.
We didn't have teeter-totters at our school.
I don't know, we had the merry-go-round of death because everyone would run for it and we try to fire other kids off the merry-go-round at recess.
You were so, then it got banned.
Yeah.
We got our tetherball pole taken. Oh, sick.
Oh, you're
Why?
dynamite.
I don't remember why we got taken away, probably because people would head it at each other. That's the whole point of the game.
Now, so this is your first representation of the cross product, okay? Now, the second representation of the cross product. I told y'all to stop playing 6, 7. So, here we go.
7, 8.
So now we're gonna talk about twerking in a circle.
One that she.
Actually, we're gonna talk about this in terms of a map of a three-dimensional space.
Oh, thanks.
Okay, does anyone know the mathematical construct that shows us the map of a multi-dimensional space?
Three.
Yeah, do you?
Yeah, I'm gonna say, I'm gonna go with, yes.
Mad at myself. I'm gonna go with no.
Yeah.
I'm working with Hilbert space.
What?
That's not a real thing.
Oh, yeah, it is.
It's like a different symbol thingy.
Sometimes particles work in a hyperdimensionality. You can imagine 3 dimensions. Particles exist in 5, 6. Hilbert space is an n by n dimensional space.
Can you put the DC?
So some particles based off their quantum state can exist in hundreds of dimensions. You ever want to try to wrap your mind around it, think of quantum entanglement. If I have a particle on one side of the galaxy and a particle on the other side of the galaxy that are entangled, I send information through one particle, the other particle receives the information instantaneously. Space and time don't apply. So how do particles communicate around space and time? They do. So, based on that, is anyone getting the idea of what a map of a 3-dimensional space is?
No.
Yeah.
This. It's so fun. Whenever you do in physics where there's 3 of them. This way
No, I'm just in this class.
Right, so now what you're about to see is the fact. Does anyone get the joke if I said, I know Kung Fu?
Kung Fu fighting. That'd be great.
It's like compared.
Okay, your assignment for this coming weekend is a Keanu Reeves movie marathon. You gotta learn stuff.
Okay.
Excellent.
Now, okay, so
Bill and Ted's.
That's what he.
for,
Keanu Reeves is
You
not
are
fighting.
so young.
no, you don't.
Those movies are so gory, like why are they stabbing people's eyes?
Now,
God. The worst part about God is.
a new way of representing a vector.
Die.
So, different ways of representing a vector. So let's just take the vector R, okay?
Everybody that's coming.
It can either equal,
I don't know, I'm just doing that.
Always be like
What the heck is that?
Is that an R?
I'm into whatever that is. Is that a K? Dr. Ever, I have no idea what that.
no,
Or.
Oh, thank you,
Okay.
that's what I didn't know.
So we had to go get.
this is called Dirac notation. We switch between the arrow and Dirac notation when we start representing vectors as matrices.
Ew.
So, given that R and F cannot be represented as matrices, we're going to build a multi-dimensional matrix where you have your I hat,
Are they wanting this week?
J hat,
Yeah. Another one?
J hat,
Checking this. It's literally- When did it get up there? It was literally.
Y.
This shit bugs me out so bad.
Well, actually, I went to her last day to talk to her, to talk to her today, and she was talking about how she posted, it was like right after.
Starts with bubbles. Like we would just put it in that store.
Then we're going to solve this. That's the second representation of the cross product.
I do not know how to do this.
So that's the issue.
Because by the time you get done, you're gonna see three components. Each with their either their IJ or K hat, unit vectors.
We have to write all this out for.
Roasting a problem.
I'm just showing you where some things come from. Now, what I'm about to do, the reason I included so K hat is of course, you've been doing I hat and J hat, that's your X and Y directions. Now, what do you think K hat is? Z. The reason I had to include Z is this functionality is not possible unless you have a square matrix, 3x3.
The waiting hierarchy.
It can actually be any size of square matrix, it just gets more complex as you go along. We are going to take what's called the determinant. So the way you start looking at this is, we're gonna take, first, we're just gonna pick the I hat direction. When you look at this in a matrix, what you do then is I'm gonna go down I hat column and across I hat row, and all those are left out. I get a sub matrix. And you notice that the sign on the front of the I hat is a positive. There's a whole lot to that, something called a parity operator, but basically what you do is you add the row and column together. So this time it's row one, column one. If it's an even number, it's positive. If it's an odd number, it's negative. So like row one, column two, 1 + 2, that's 3, so it'll be negative. Okay, so in similar fashion, what we're gonna do is now we're gonna take the J hat, row one, column two, so it's negative. And then we take the submatrix outside of everything in the row column combination of J. And then the K hat, it's row one, column 3, so it's a positive number. And we take our last submatrix.
I do.
So now we have one more step we have to do. We have to solve the 2x2 determinants
She is.
So when you have a 2x2 determinant, what you do is you're going to cross multiply and subtract. So what it's gonna look like, you're gonna have RY times FZ minus RZ FY. That's your I hat component. Minus RX times FZ minus RZ times FX. Your J hat. And then you're gonna have
We're using my.
RX FY minus RY.
It's not spicy, but mine's not sweet. Yeah, not
Say
sweet
that.
either.
So this gets you, this ends up getting you to your second representation of the cross product. It's more or less to show you that this is in fact a vector product, because when
Never had
you
it.
do the cross product the long way, you end up with a vector with three components.
Like this, he puts. It's like, it just makes it a really good.
So-
taste, but it's not really that.
Probably your first foray into linear algebra.
I have no idea what's.
It's because you're on social media.
No, I just took a picture of the thing and I'm copying it down because I can't see.
Okay, now. These are your two representations of a cross product. Let's go back to making this a little easier and talk about how we actually get to the center of mass equation when we're basing it off of torque. Okay? So of course, you can compare this to the torque to the center of mass equation above. This is your more generalized format of center of mass, because of course, when you see you have your R vectors, you're gonna see that we can break the center of mass into X and Y, X, Y, Z. You can do individual components. Okay, so given that, let's just say we have one of our masses. Okay, it's at some position X. And it has a gravitational force, okay? We have, let's see. So your torque is going to be your
This is not true.
R
Don't say that.
F
People believe you.
theta. And then you have to ask yourself, what's the theta between these two angles?
90
I'm
degrees.
saying you can't say that.
90
People would
degrees.
believe
90 degrees. So what's the sine of 90 degrees?
Pi over 2.
you buy.
Or am I crazy?
I do buy juice.
But
No, I don't.
90 degrees is pi over 2, but that's radians.
Jada, because she was feeding me.
So then what's the sine of pi over 2?
Cheese curds in my car and I would have said.
Pi over
buy
two?
her
Do you remember your graph of the
dinner.
sine function?
Yeah, I'm trying to remember. Is it 1?
It's 1.
Yeah, right?
So sine of theta, sine of 90 degrees is 1.
Oh, I knew that. Sorry. It was literally what.
That means we're just gonna get R times F, okay? Or R times mg.
They just bit me yesterday.
And so we can already start to get to a point where we have torque.
So there's a bright mark. on
It's going
my
to
back.
equal delta R mass times gravity.
Back, like, on the sweatshirt. So she must have just bit my shirt.
Okay, now
She also got really mad at me.
you want to realize,
I took her, she was eating like a piece of food.
we want to realize that delta R,
She slammed her head. in my
this time we're
face.
going to define it as,
You have a picture of somebody don't slam her head. Me too.
because you remember our pivot point is at the center of mass.
R what?
R sub I
You're so weird.
is not initial, that's just any random R.
Centimeter, but like central mass, right?
Yeah,
She wanted-
because remember, the center of mass is the pivot point, so we're measuring our directions to our mass, our distances to our masses from that center, from the center of mass. Okay, and then we think back to, well, we had mass 1 and mass 2. To figure this out, what we want to do
I know. She figured.
we're going to do some of our torques. So that's gonna give us M1G, R1 minus R, center of mass, M2G, R2, R center of mass, and the system, and so was the system rotating? You said the system was what? Yeah, so it's balanced, which means this whole thing equals what? 0. And now we can go ahead and solve. So we can say, well, it's gonna give us M1G R1.
It's not looking like this, to the left. No, try something else. I'll just do outpatient, so it'll just be allowed to.
Do that.
I'm going home. I have surgery after this.
Let's go ahead and put our R1 and R2 together and our center of mass together. So we're gonna have M1G, R1. Now, because every component, every part of this has a G in it, and the right side of the equation is 0, what do we do? Yeah, we can just divide G out. So I divide G out of the left side, the G's go away, I divide 0 by G, I still get 0.
We divide G out.
Yep.
When is
Yep.
it?
Why do you want
I can't tell you why.
like that? To make like.
Because we're trying to figure out why the center of mass is what it is.
I hate when we do.
You know, some days you guys are lucky I'm already a damaged person, or else the things you say would really hurt.
You know what hurts my feelings?
Well,
When you say, yeah, I just want to make your guys' lives a little bit more miserable.
isn't that what college is?
No.
No. So,
Private school is the best years of our lives.
Yeah, every level gives you a little more trauma. That's what being an adult is. It's a collection of trauma.
no.
You make mistakes when you're young because you still have hope for the world, but after you've tried stuff and it's gone bad, once you're an adult, you're like, nope, not doing that anymore.
What happened to life being happy?
You're becoming adults. It's going away.
You guys are cynical, guys.
Don't you guys listen to the Muppet song where it's like life's a happy song?
Okay, so what do we have here? Let's go ahead and group these.
Disgrace that she doesn't like.
Have you ever seen the Muppets Christmas Carol?
So if I pull a negative out of those last two terms, what's inside the parentheses?
Positive.
Yes, so it's a plus, you're adding those two.
Yeah.
So I pull the -1 out.
Yeah.
So then I'm gonna have
Oh,
M1,
You should have been sent that to you.
our center of mass, plus
No, she
2,
wants to go to oh, don't worry.
our
You
center of
just
mass,
afford it.
0.
Oh, I took it over.
And now I can move those to opposite sides of the equations. So I can have
I know, and I thought. you
1
guys-
R mass,
I can still go.
Why don't we just put them in parentheses and now take? I'll move
Okay.
this out.
so I can pull the R of the center of mass out.
I can still go if you want, but I'm just not on Senate, so I just thought. maybe-
And then, of course, we get to your center of mass equation. Okay, so we get to the center of mass. This is generalized for the two masses, okay? But you could do this for any number of masses. So your R center of mass,
Do it just a tiny. Just trying to figure out my signs.
do I. So we could do this for any number of masses. Which ends up giving us our, and so we get to the generalized format at the center of mass. Now, of course, since R is a position vector, we could just take this equation and apply it to any dimension. So your center of mass in the x direction your center of mass for the y direction and of course, we could write a z direction, but we're not, I mean, we're still pretty much working in 2 dimensions. But the good thing about this is if you're trying to find the center of, imagine you have masses across a 2-dimensional plane. You can separate this into x and y, and you can find the coordinates of the center of mass by doing center of mass in x, center of mass in y. That will give you the coordinates of the center of mass.
Yeah, I'm not.
So a good way to think about your generalization is, let's say we have one,
I'll let you.
two,
Thanks.
that's 3,
Okay.
and 4,
He said that's my house. Did you still?
we'll just pretend that's a straight line. So you have your x direction,
I have no, I just.
this time we have 4 masses applying a torque. And so then you just start analyzing this.
If I knew where it was, I would. We're not solid. You should see that. Is he upset with us? She's not gonna help.
I knew you would find that. I knew you would say
It's gonna
that.
get worse.
Okay, so in this case, what do you think your center of mass would look like?
Probably be a little bit.
Was it? Imagine.
Center of mass of y is 0, they're all on the x-axis. But we would have m1, x1, m2, x2.
Whoa. That's cap.
That makes me feel better.
So in this case, again, you see an extension from the 2-mass system to a 4-mass system. So you're just going to keep adding together your mass and your position until you're just going to keep adding to this until you get to the end of your masses.
Well, what is this telling me?
Well, this will tell you, so what center of mass is the reason it's important. So again, we talked about, for example, why, and someone remind me, why is the center of mass for the earth, the center of the earth?
It says center of mass.
No.
Because we're balanced.
Why are we balanced?
Cause it's all the way around.
All the way around, what's the shape?
Circle, sphere.
Sphere is symmetrical.
I don't think it's.
A symmetrical object, your center of mass is gonna be take a cube, your center of mass is at the center. Okay, rectangle, believe it or not, rectangle, center of mass at the center. So for symmetric objects, it's easy to find. But you could also model the earth as almost an infinite number of tiny little particles of mass that you would have to sum together to find the actual center of mass of the earth. But, well, you can do the long version and it's gonna involve calculus and whatnot, but you can find the center of mass of a symmetric object, but you're always gonna find the symmetric object at the center.
We have questions.
Yeah.
What? Earth, right? What if we just had this?
Leave a little heavier on one
A
side.
ton of mountains, big, tall, huge, heavy mountains on one side and like done, just ocean on the other side with your center of mass.
I don't know, maybe they.
But you wouldn't really have a symmetric pattern then.
But it's not a sphere.
How is the earth a sphere?
It's
though?
not- it's like-
It would still be a sphere, wouldn't it? It just wouldn't be symmetrical. So then where would the center of mass be?
For 100 level physics, we're going with sphere. Trust me, you wanna go with sphere.
But like, think if there's more people
Hypothetically, let's,
China than
let's
it is-
waste class time and talk about this.
Is there an area, what if that contribute to the center of the mass? as
Yeah,
well?
but then you're gonna have to take into account an average of that happening all over the planet. You're gonna have some more populated areas, some less populated areas, some
But like
areas with
Antarctica.
cities, some areas without cities, and it's gonna be randomly dispersed across the planet where it averages out to almost a symmetric pattern.
What about Antarctica, like the North and South Pole though? But there's no one up there, then how does it get to the middle then? Wouldn't it be more like oblong shape if that was the case?
So that's why I'm saying you, for physics 100 level, you're gonna wanna go with sphere. Because the Earth's shape is not technically a sphere. As it spins, what happens to the Earth as it spins? And the momentum around the center of the Earth, so the momentum at the center is greater than the momentum at
Why you're
one of the
asking.
poles. What happens to the shape of it?
You get this
Squashes.
See, that's what I'm saying. Does it-
But you don't wanna do that math. That one, I mean, it's not an oval. I don't know, like, take a ball and just kind of squish it a little bit. Like, what-
They didn't name that shape.
Well, not that I know of.
Like that Nerf ball that you could squish flat and throw it.
You should name the shape and then claim credit.
That's not far from the truth because the Earth is sitting on the back of four elephants riding on the back of the cosmic turtle. But that's,
Oh,
you know that?
Wait, say it again. We're sitting on,
Sitting on the back of four giant elephants that are riding on the shell of the cosmic turtle.
Did you hear about that?
what?
This is Shell World.
You never heard
isn't it?
about that?
You know where it's from?
Oh,
Yeah, it's a real book series.
It's from a series of books that were turned into some like bad movies, but
Oh, yeah.
Isn't that like Discworld or
Yes.
something?
yes, it is.
Detail, it's like this.
I've never read
Like
it,
that.
but I was recommended it.
But the reason we work with center of mass is because a lot of times okay, remember the amorphous mass that we started with where we had individual little points of mass inside of it? Okay, but
That's the real deal.
That's honesty.
I could just come to campus intoxicated. No one would care. Like, it wouldn't matter.
I would not report you, cause I'm not a snitch.
Share.
Can you do it once to see if
No,
we can tell? Like everyone is so fast.
It's not something, it's not a good thing to do. I'm just saying I could do it. It just wouldn't matter.
What would you do?
Yeah, it really wouldn't.
Okay, so,
No.
but when you have a bunch of masses together and it's just, so imagine like these four masses, imagine they're all connected by like a solid bar. Are they acting individually?
At the bar?
No, they're not. They're gonna act as a single system. And that's why the center of mass is important, because then the torques of each one of these individual masses can be drawn together into the torque at the center of mass. One singular torque moving a single distance. So a lot of what we
Is that right?
do
You show up
is
in
gonna
the
be
middle,
based off
trust
center of mass, because what is done to the whole group can be evaluated at the center of mass, because they're going to act as a single system.
I have a question because I came in late. If I wear a Halloween costume on Friday, do I get extra credit?
Oh, yeah, I already said, yeah, I just wanna see what y'all come up with.
Okay, well, I was coming late because I had to make soup.
Yeah, but it'll be over by the time class starts.
Can I show up in a jersey? That counts?
Yes.
I mean, I guess if you're pretending to be an NBA player, that really would be a costume.
Oh, dang, man, that's me. Okay.
Eat
I mean, if it counts.
First off, like, I think like the minimum height for the NBA is like 6'5".
Oh, I'm like 2 inches off.
Dang it, you're ruining my dream. I should wanna be in the NBA,
I know.
not the WNBA.
Yeah, you.
I couldn't even play double.
You showed suggestions, but I just clicked it. Like unclicked it, so you're saying love her place.
It's okay. I wouldn't question it.
And I have
I guess I'm wearing a jersey.
It's gonna say request under request. request.
Not where micro.
So this is why we figured out center of mass. Okay, so let's start looking at this system here. Three spherical objects, and I'll show you the figure.
Those glasses.
Yeah, my nieces.
Do you want some Ray-Bans?
Need those Ray-Bans, no.
I have a
Regular pair of sunglasses, but no, it's sneaky.
He's got a fat ass head. They don't fit in my head and I have a big head. No.
Since my period.
Coil. Everyone, what would you do if someone told you you smelled like coil?
I don't know, but last year, someone commented that I look like a Discord mod, and I don't know what that means.
That is really mean. That's not a good
I'm
thing.
guessing it's the best thing.
It is.
It just said it's really mean.
Yeah, you don't.
Yeah, it's building tea.
I don't know.
You smell like people kidding. Okay, then it's deserved. Then it's actually.
And you didn't immediately Google it?
Yeah.
Well, don't do it on the school internet.
Get a couple of decades older.
Those are like some of those roasts.
Stops here.
Those are like those roasts that are like low key true, and you're like, damn.
Baseball hats.
One time when the middle schoolers, the middle schooler, shut your Megamind head, look at that. But all I could do not to laugh, because I had to be like, that is mean, you cannot say that.
Did you see,
That's one of the-
Sometimes like the roast is just too good, you're just doing it.
Yes, it was so
Take back.
Nay, no, it was key. Key one is. The volleyball, it's so good.
They actually ate it up.
I had to go.
They started popping up on my For You page
My
on
picture
TikTok.
mess, please.
And Bo's
Probably
one of her
get it
very
for
practice rocking
Yeah,
around.
goes mass one equals mass.
Bo had one.
Oh, put the gas point with gas
They were
too.
like riding like one of those like scooters,
Two.
like old people scooters, and it had like 2 million likes.
What's mass one? Oh.
They ate it up.
I don't know what's up.
So then you have to find the center of mass of this. So mass one equals mass two equals 1 kilogram.
Yeah, I like the chicken.
And then mass three is 4 kilograms.
I already know mass two is all the way up that y equals 3.
Because this was the diagram. You're being told this is your system. You have to find the
Oh,
center of
okay,
mass.
okay.
Secret mass?
The center.
Oh.
Did you say the secret?
I think I need to get my hearing checked.
Word that is secret. Yeah.
That's like this.
Well, Tracy spells his name weird.
There you go.
One of my neighbors, his name is Tracy and spelled capital TRE apostrophe capital C. Tracy.
See you.
It happens.
Wait.
Y'all are lucky I don't do the clean skill substitute.
I would love that.
What's that?
That would be so funny.
Wait, Who said what that?
Somebody, have you seen the one
You
where
just
they
don't know what
make
that
the
is.
football
Hey,
name?
Ron, be nice. Yeah, you know
Where
that
he
one.
dresses his
I
as
was offended.
and they do the football names. I saw somebody do that as their Halloween costume. It was so good.
We'll have to finish solving this next time. I want to find the center of mass, okay? But you notice that these objects lie in both X and Y directions.
Yeah,
What am I gonna have to do? So what am I looking
Figure it
for
out.
when we're taking?
your X one
So I'm looking for, the center of mass will have a pair of
coordinates,
coordinates. And so I have to find the center of mass
so the X and the Y.
and the X and the Y. Yep, we'll finish that, we'll finish that next time.
Wait.
Is it gonna be at 2-2?
I wish we were this. Dude, I wish
I
we
would so do it.
Hello.
Like, what if I just put that on a test, like 2-2, without any math?
Class.
Would I get like 50% credit?
Actually still in class, but.
I mean.
There's one equals, yeah, change, M one equals M one.
Oh. Then one equals that too?
What?
Why did you put M where you did?
What is you doing? Just let it go.